Hi. Yes, while this video is called Introduction to Circles, I'm guessing you've already seen several circles in your life. You've already probably known how to identify a circle since you've been in kindergarten. So instead of thinking about this video as an introduction to circles, perhaps we should think about it as fun facts about circles. Okay, so before I can really describe to you what a circle is, you first have to understand what a locus is. A locus is a set of points whose location is satisfied by or determined by one or more specific conditions. So let's create a specific condition here. All right, let's say that's me. And I, for some reason, can only walk a mile. I can walk that mile in any direction I want to walk it, but I can only walk a mile. So if I walk a mile in this direction, let's say I end up here. But if I walk a mile in this direction, I'll end up here. And if I walk a mile over here, I'll end up here. And so I'm going to get a series of points that are going a mile each. Well, I don't have a ruler or a protractor or a compass or any special tool, but I'm doing my best here. So this series of points are satisfying the condition that I just described. And that series of points is called a locus. And in this specific case, because we have the same distance going in every direction, this particular locus is called, you guessed it, it's a circle. All right, so a circle is a locus or a set of points in a plane that's equal distance from a given point called the center of the circle. And yes, the center of the circle is my head or my foot or me. All right, so that's the center of the circle, and going around, in this case, around here, is our circle. Now, the mile that I was allowed to walk, that has a special name as well. What is that called? If you said it is called a radius, then you are correct. You remember your stuff. All right, so now we're going to move forward and we're going to look at the different things within a circle that we can name. And the first one, of course, was radius, but there is so much more. Okay, so here we have a circle. And in our center of the circle, we have a point called the center point. And I'm going to name this center C. We could name it any letter really, but I'm going to call this center C. And if the center is C, then the name of the circle is also C. So we have here, I could say it in words. I could say circle C, or I could call this circle with a dot in it. One dot, not two. C. All right, so that's the name of the circle as well. So whatever is the name of the center will also be the letter that we use to name the circle. All right. We also spoke about the fact that the radius of a circle is a segment with endpoints. One endpoint is at the center, and the other endpoint is on the actual circle, out here. And there are actually infinite radii. Radii is the plural of radius. There are infinite radii in a circle. So we could have a radius there, we could have a radius there, we could have several radii. Okay, so another thing that we have to speak about is the chord, or a chord of a circle. A chord is any line with both of its any segment with both of its endpoints on the circle. So if we have an endpoint here, an endpoint here, if I join it, I have just created a chord. So here's a question to you. Is a radius a chord? If the answer that you said is no, you are correct. The radius is not a chord because the endpoints have to be on the circle. It has to be out here and out here. So I can, however, have a chord that goes through the center from one part of the circle to another through the center, and that is a chord. It's a chord and it has another name. So a chord that goes through the center has another name, and the name of that specific chord is the diameter. So the relationship between the radius, which we have right here, and the diameter is very specific. Let's talk about that right now. I'm going to get a nice fresh circle so we can have this conversation. Okay, so we were just talking about the radius and the diameter, and we said that the radius goes from the center to the circle. And we said that a diameter goes from the circle through the center, so through the center and out to the other end. So a diameter is actually made up of not just one radius, but two radii, which means that the diameter of a circle is actually 2 times the radius. Or you could look at it in this way, that the radius of a circle is half the diameter. I don't think that's going to fit, but you can imagine that's diameter. All right, cool. So the radius is always half the diameter. The diameter is always twice the radius. That is super important for us to know. All right, so let us go ahead and talk about a few other fun facts about circles. Okay, so we're going to spend the next couple minutes looking at circle pairs. All right, so how can two circles be congruent? Are these two circles congruent? Absolutely not. You can clearly see that just by eyeballing it. But if I made the second circle bigger, then it will be congruent if the radii of the two circles are the same. So now if I went ahead and measured the radius of this circle that I'm moving and the circle in the background, the two radii will have to be the same, and that's the only way you get congruent circles. All right, how about similarity? Well, the cool thing about circles is that all circles are similar. They all have 360 degrees going around. The sum of the measures 360 degrees. There's nothing strange going on, no lines making it up. So all circles are actually similar to each other. Okay, so the next thing that I want to talk about is concentric circles. And so when you think about the word concentric, it actually means what it sounds like it means. It's two circles that have the same center. So it's not quite right now. So now if I have two circles that look like this, kind of like a bullseye, then the circles have the same center. And so therefore they are concentric. But there are a couple more things that we have to think about when we are thinking about two circles. And this is really popular on SAT questions, you know, to be able to think about how can two circles relate to each other? How can they intersect? So in our concentric circle, there is no point of intersection. We can also have no point of intersection if I took one of my circles and moved it entirely out here. So there's no point of intersection. But my circles could have one point of intersection. How could that happen? Well, I could take that circle and move it really close like that. And now it doesn't look like it because I have the white line on here. But now my circles have one point of intersection here. We'll pretend. All right. It can also have one point of intersection from the smaller circle being on the inside. So I could take my circle and move it over here, and it has a point of intersection on the inside, which again it looks weird because I have a white thing around my circle, but that's, you know, you get the point. So we can have, I'll draw it out here just in case, we can have the circles touching each other from the inside or touching each other from the outside. Wow, I'm doing a terrible job at that. All right. We can also have 2 points of intersection. And if we have 2 points of intersection, then it would look like this. Let's just complete this circle so we know exactly what's going on here. All right, so yes, if I have 2 points of intersection, that's how it would look. All right, so I'll wrap my fun facts about circles up at this point. Haha. And I'll see you in the next video.